озвучу. Так, доброго всім дня. Зараз, ми з'явилися тут, от, щоб не перекрити. Доброго всім дня. Ми, невзирая ні на що, ми продовжуємо наш семінар. Сьогодні в нас буде доповідь нашої колеги Ганни Portyankiної. Вона наша випускниця, тепер вона співробітник університету Колорадо. Ну, вона ще більш детально представиться. Давайте одразу домовимося про процедуру. Процедура така, значить, ми зараз слухаємо семінар, доповідь іде у нас в прямому ефірі в Zoom і йде в прямому ефірі через Facebook. Після завершення доповіді переходимо до відповідей, запитань. А спочатку давайте це голосові запитання в Zoom проведемо. За цей час люди зможуть написати свої запитання в коментарях до відео. І тоді або я озвучу, або Аня може сама їх тоді. Аня, у вас же ж є доступ? Ви ж зможете відкрити вікно паралельно десь?
Ну, після доповіді так.
Добре, ну розберемося. І після цього, значить, ми робимо сесію відповідей на письмові запитання. Ну, тепер я прибираю наші зображення з екрана. Ось, і надаю слово доповідачу. Аня буде доповідати англійською, ну, вже відповіді, запитання, ну, кому як зручно. На мовах, які хтось розуміє. Там українська, російська, англійська, хто знає клінгонська.
Клінгонська не вийде, я
не
знаю.
Ви не знаєте. Да? Ну, добре, починаємо.
Добре. First of all, do you all guys see my screen, my presentation? It should have a big NASA sign on top of it. Someone say something. Okay, somebody sees it. Great. So then that means that I don't hear you if you said something.
We see it.
Okay. Do you see also my mouse pointer?
Yes, we do.
Great. So this is a talk about how to write a mission proposal for NASA, or better to say the overview about NASA process of how it is done, how NASA chooses their missions, and how people who want to create a new mission should go around doing that. I want to immediately say that this actually was inspired a lot by Catherine Arends. That's my friend who works in Arkansas Center for Space and Planetary Sciences. And she gave this, or I should say, very similar presentation on a big public event, which I've seen. And I thought that it's quite useful for everybody who is working with scientific data to know how missions are planned and selected. And a lot of images and tables that I use in this presentation is from the talk given by NASA Associate Administrator Thomas Zubruchen. He gave a seminar in Boulder and I went to see it, and I could use some of his graphics, of course, very highly professionally made, for creating this presentation. So what's the motivation for doing this? As you will see, not so short, not so easy job of writing a mission proposal. The main motivation behind that people want to do what they are most interested in. So they want to get the data from their favorite target body and study exactly what they want. So choose your own adventure is basically the motivation for being on a mission or leading a mission, either or fall into this category. This is the agenda of the talk. So I will go through a little bit through introduction into NASA programs, some very required nomenclature and specifically about mission classes. And then we will go through discovery program process. That's the discovery class, stepping a little bit ahead, is one of the programs where I have participated. I was a part of one proposal, which unfortunately was not selected, but at least I can share some of my experience about that. Then I'll touch about writing a successful proposal, which mostly is from Zubuchen's presentation. So talking about what NASA expects about the mission proposal, how it should be organized and what to pay attention to. And some final thoughts at the end. That's kind of very normal. So let's start from NASA program. Of course, remember that NASA is much more than a planetary science only. You in all NASA parts, actually. NASA has Joint Agency Satellite Division. That's one together with Atmospheric and Oceanic Administration with NOAA. They do missions together in that division. And then there is known to public 4 parts of NASA, first science and planetary science. So we are all here interested mostly in planetary science, but if I pull up this nice next graphics about NASA fleet, you can see that actually majority of missions that NASA does is focused on Earth, which is a valid approach. We want to know a lot about the planet where we ourselves live in. So most of the green parts here, this all. Hello.
Hello.
How long did you lose me?
Like 5 seconds.
Okay. Okay, let's go back to it. I don't understand why sometimes it's like completely disappears everything.
It might have been my fault. I think it happened just when I took print screen of the slide. As I'm the organizer of the meeting, it might be very sensitive to what I do. I'm sorry.
Okay, so you see my slide now?
Yes.
By the way, if you want to have any of this, it's publicly available, so I can share this presentation with you guys, if you want to have any of these graphics.
Thank you very much. Continue.
So I was talking about that the most of this green part here is the NASA's focus on Earth, and we are this little pink ones, smaller probably part, but of course for us, for our interest, is the most important. Okay, that's introduction in NASA, and let's go to nomenclature that we need to understand the process of NASA mission selection, which includes mission classes. These are all annoying things, and you can see in this table that, and this is only a small part, I should say, of special terms that is used in this process. Maybe the most important one is PI and COIs. So PI is the principal investigator. That's basically the main person on the mission. And COIs, this is scientific co-investigators. That's the core team of any mission. And I should say that there are more team members than COIs in every mission. There are also, for example, engineers. They don't have a role of COI. COI is kind of restricted, given to people who do science. They are the first to start planning for the mission, and they also basically the last users of the data of this mission, the most important core of the team. AO, or announcement of opportunity, that's basically a call for competition. That's when NASA issues basically a statement saying we want you to submit a proposal that will become this mission with such budget and other requirements. Mission of opportunity, sometimes it's MO or MOO, is a specific type of missions, focused proposals to leverage specific flight opportunities. Very often, this is when NASA wants to collaborate with other space agency, with ESA, with JAXA. So this is very often only for instruments instead of full mission, or even a participation in another instrument as a COI. Technical management and cost, TMC, that's engineering, cost, schedule, everything which is not science on your proposal. This is very important part. I will mention it several times down in this presentation. Preliminary major weakness, PMW. This is something that NASA headquarters can send to the team as a question for potential explanation, clarification. So if NASA doesn't understand something in your proposal, they will issue that, and you can react to that, answer that possible weakness. Debriefing, I put it in here, even so it should be understandable for native speakers of English, but for people who come from outside is a not very used word. It's formalized discussion between NASA and proposers about actual mission. So it's an official, basically, meetup, or at our times, it's probably done with Zoom. So people can ask NASA why something was a problem in their mission, how their mission was evaluated, things like that. So it's a conversation between NASA and proposal team. Step one in this presentation will be about the first phase of a mission competition. Concept study and concept study report is something that comes after the step one. So that's period of time when the team actually does the concept study, which is advanced development of mission beyond the proposal. So when you start actually to plan your mission with more concrete deadlines and general schedule of the mission and the realistic budget and all that. Step two is the second stage of that mission competition. Also, I'll show the whole process as a diagram down later. And down selection is the final selection when NASA chooses actual mission that will fly, that will proceed to actually building the hardware and creating, launching a vehicle and whole spacecraft. TRL was added here last moment because I actually talk about it a little bit, but it is whole big can of worms. Its technology readiness level tells you about the hardware, how well it is prepared to fly. So there is different levels from 1 to, I believe, 6. And 1 means that it's just the idea, and 6 means that there was actual hardware that flew to space. So in between there is a spectrum, and this is very important thing to know because every piece of your mission, every piece of technology that is used in space has that TRL assigned by NASA, and it has to be above specific level, and that depends on the stage of the proposal or stage of the mission development, which one it has to be, but it has to reach that level before NASA actually agrees to fly it or even consider it for flying. Okay, so I will hopefully not use overwhelmingly much of this, but it can slip because I'm used more or less to this all definitions. Again, you can get this from me later if you want to, remind yourself. So next one is what is important to know as mission classes. So NASA uses this 3 main classes: Flagship, New Frontiers, and Discovery. And I will step through them in a moment. And MOO, as we just learned, is missions of opportunity. They usually are included in Discovery. There is also another class description, which is so this valid for basically all NASA missions. Discovery, New Frontiers, and Flagship is the terms that used in planetary science. But beyond planetary science, NASA used Class A, Class B, Class C, and Class D. And you can see here that, for example, medium lifetime large mission with high priority and low risk would be Class B. In our other definitions, this is what planetary science called New Frontiers. Flagships are Class A, Discovery are Class C, and the very small one, which I will not talk about, is Class D, and this is very often, for example, something like a CubeSat or in addition to a bigger mission. So they are sporadic programs, and so it's a little bit hard to forecast when they will pop up. For example, there was the most recent one, I believe, was about addition to Indian spacecraft to Mars, which was very unexpected, and I even don't know how it went because I've heard that people didn't really have anything on their shelves ready to go for such opportunity. So we will not focus on them, we will focus on the rest of this diagram. And starting from Flagship. So Flagship is not competitive program, it's headquarters directed, and it's large strategic science missions. Budget of this mission is usually above 1 billion, and it's set by NASA. It's restricted by NASA. Every time it's different. Here are some examples for you of which missions were in Flagship class: Viking 1 and 2, both Voyagers 1 and 2, Galileo spacecraft, Cassini, and currently still working Curiosity. So out of these missions right now is only Curiosity that is working. But we are expecting a launch very soon in July 17 of Perseverance, is the next Mars rover. And in a couple of years, Europa Clipper also is being built right now. So this all are the biggest missions that NASA builds. Europa Lander is proposed for launch in 2024, but right now it's kind of in the air if that will happen or not. I should add that NASA decides about these missions in the highest level. Very often, this is where politics plays in. And for example, we have Europa Clipper because of one very enthusiastic congressman who was pushing for it and actually made a special case in NASA budget to support this mission. So this is a little bit top-down approach instead of everything else that NASA does when it's bottom-up. Next in category in price is New Frontiers program. So this program is competitive. And this is PI-led missions, of course, solar system targeted, with budget capped at 1 billion. And the recent and currently working examples from New Frontiers and New Horizons, Juno and OSIRIS-REx. OSIRIS-REx was the last one to launch, and the Dragonfly was selected a couple of years ago, I believe, and it's set point 2026. So this program is issued about once in 5 years. So we expect the next call for this in 2022, maybe end of 21. So right now, institutions are preparing for proposing in this program. So this is the next big thing for people like me, if one manages to get on one of or other mission proposal. And the discovery proposal, this is the one that I will be focusing from now on. This is also competitive. PI-led solar system missions with budget below 500 million. So half of what New Frontiers take. An example of this type of missions are Mars Pathfinder, Stardust, Messenger, Dawn, Grail, and most recent Insight, still working one. And there is Lucy and Psyche are being currently developed and being launched in 21 and 22 accordingly. And this is the one that just had selections in February, and they went through step 1 and first down selection, but this is not the final list. So there is 4 missions that right now are working on their concept studies. Trident, Ivo, Veritas, and Da Vinci, and I later on will tell also about each of them a little bit. So this is the last big thing that happened in NASA. Discovery program also includes missions of opportunity. As I already said, often they are collaborative with foreign space agencies. There is 3 right now in kind of development. One of them, for example, participation in JUICE, that's the European Space Agency, and DART and Europa Clipper is in this mission opportunity program as well. So, discovery program process. This will guide, it says my internet is unstable. Can you hear me still? Okay, great. Thanks for saying. So let's do the discovery program process. How to get from an idea to a mission. So this is the step our mission proposal went through. So let's step a little bit one by one. So the biggest part is the one in this bright yellow over here that says partner, prepare, and plan. Creating, figure out which institutions can support them, which providers do they need? For example, who would provide a spacecraft bus, basically the basics of how to say spacecraft, the cube to which everything will be attached. Who will provide communication packages? Who would provide mission design, operations, and so on? So this is the biggest part. This part is not structured by NASA, so everybody does it on their own. You talk to people who are doing the things that you are interested in, and basically go to conferences. This is the part where you have to be active to actually get involved. It's very rare that somebody calls you up and tells you, like, let's do the mission. It's usually the other way around. People chat after somebody's presentation about a nice instrument or about the idea of what we should do next for, I don't know, atmosphere of Mars, measuring something in it. Then at some point, announcement of opportunity gets released by NASA, and that determines what you actually need to write in your proposal. Everything, what has to be covered and how the mission has to be operated, all the details are in that. After that, NASA usually does pre-proposal conference. So that's where NASA officials would show what they expect from the missions, and for example, the talk that they was in the frame of this pre-proposal conference. Next step is when notices of intent due. So notice is basically the statement from a mission team to NASA that we are going to propose. Without it, you cannot submit later the proposal, and it's a couple of months before the final submission of proposals. Then there is a deadline when electronic proposals are due, and NASA still wants some data on CD-ROMs, so CD-ROMs get sent around to NASA. And we jumped out to this checks. There is compliance checks of proposals first, so that is very technical on if the proposal is correct length, if it has all the components that it has to be according to the announcement of opportunity. Usually proposals don't fail this check because it's far too to actually get evaluated. So teams do pay attention to this. This exists, but this step usually all the proposals come through. And the evaluation kickoffs is basically the time when NASA asks for review panels. If anybody of you participated in the review panel of usual research proposals, this is very similar. So they ask people to come to meeting and basically read all the mission proposals, or one of them. It depends. If you are a specialist only in one, you probably will be assigned to the specific mission, and evaluate it, give a feedback to NASA, write a review of that proposal. Interesting part is this evaluation, that is the next step. TMC, so technology management and costs evaluation. So everything but science is basically one team, and the science evaluation is another team. So engineers do TMC evaluation, scientists do science evaluation. NASA may ask the proposing team for clarification and get the answers, and it can go in this circle for a while until everybody is satisfied. Both of these panels or teams give comments basically to NASA on a science meeting and plenary meeting of TMC. They exchange comments, and then the final report goes to categorization committee. Categorization committee, tongue twister, does put every mission into a category, and I will show you that distribution later on. Then this categorization, together with all the comments from all the evaluation, goes to a steering committee. Steering committee is a selection of top officials in NASA who actually make a decision. And they make a selection decision on which missions should progress to step 2. After that, all the teams get first notified if they were selected or not, and then they get a debrief. So that's the word that I had to learn. So basically talking to NASA about what evaluations they received, why, and sometimes maybe arguing about changing it, but usually it doesn't help. And then the successful proposals initiate concept studies. So this is the whole overview process in a glance, and I want a little bit to step through some of the steps, not all of them, because just because that would be a whole another topic. Because not all of them are important. So the most important one, the first one, is partner, prepare, and plan. And mission teams spend most of time in this one. Here is basically this is the team of a potential mission. You can see there is PI core team. That's probably a PI, a project manager that helps PI to organize all this, and deputy PI, who is the second in command after the PI, and probably some COIs or maybe leads of the instruments that are on this mission. And around this core team, there is all the institutions that are involved, PI institutions, so that's where the PI is from. Science COIs, so people like me who participated in the science part, and our institutions. So in this case, my institution is LASP, Laboratory for Atmospheric and Space Physics. There is also spacecraft providers, instrument providers, mission management organization. That's very often the same that either PI institution or COI institution. So one of them would manage the mission and provide people working on it and resources. And there is also new technology providers or users, which are usually outside of the rest of the institution. So when you are doing advanced new technology instruments, you need new technology providers, basically companies that do some cool new developments. So I can give examples of how the solar proposal that I was on. This is called Climate or Mars Atmospheric and Subsurface Science. So this was our proportion. PI of this effort is Shane Byrne, who is at Lunar and Planetary Laboratory at University of Arizona. And deputy PI is Paul Hain, who is at my institution at LASP. That's why the PI institutions in this case were those two laboratories attached to two universities. So just very fast mission goal for our proposed investigations was to link the current climate of Mars to its long-term climate record. So basically do what we do here on Earth with our ice cores from Greenland or Antarctica, where we can correlate the inclusions in the ice to past climates. Of course, we cannot drill with the same precision on Mars yet. So we propose to do it from orbit. And there is two sub-goals outlined here. We want to understand the interaction of the climate and ice. and we want to map and quantify volumes and layering of ice reservoirs globally on whole Mars. So talking about and another one. Hello?
What was talking about?
Okay. Talking about Microsoft PowerPoint. Let's get on. Okay. Talking about a partner and team and finding the institution. This is the whole structure of our Compass team looking at institutions. So as you can see, we had 1, 2, 3, 4, 5, 6, 7 different institutions in our team that had different roles. University of Arizona was PI's office. They would take on science operation and mission assurance. Our University of Colorado did project management. We provided a spacecraft and we would do mission operations. So basically run the trajectory of a mission and upload and download all the data. We had Canadian Space Agency providing one of the instruments and Jet Propulsion Laboratory providing 3 more. Applied Physics Laboratory providing another instrument, that Maverick, that the camera, which I was part on. Avionics would come from Magellan Aerospace, that's a private company. And the deployable reflector would come from Harris Corporation, that is actually a Canadian company that creates the radar reflectors.
Anya, excuse me. I have a presenter's view at the moment so that I see all the slides simultaneously. Do the others have the same issue?
That's weird. Okay, let's see. Anything changed?
Yes, now I see just the slide I should see.
Okay, good. So you do. So you also can see here all the key personnel, but I have another slide about actual people participating in this team. So you see all color coded by the instruments that they were supporting. The radar had a lot of participation from outside because actually it was provided by Canadian Space Agency. There is also a radiometer, submillimeter, the infrared instrument, and the imaging team that actually mostly was from US. But you can see there also the distribution of different institutions that participated. So you can imagine that managing such a team and writing the proposal is quite some effort by the PI. So let's go into the next step. So what happens when AO was released? So by release of AO, we actually had set up already all the participants. We knew all the contributing institutions, and we knew in how to say the big top view what our mission will be. And then the AO released, and here is the front page of that AO that got released on April 1st, almost exactly 1 year ago. And it was a 142-page document. And it's outlined all the requirements from starting from a format of the proposal, and which parts of the proposal should include. 2 requirements actual for the mission, for the budget, how to calculate the budget, and all the details. You can see from the very first page that we had to submit notice of intent on April 30, so just 29 days after release of this announcement. And then we had to submit a proposal on July 1st, which is only 2 months away. So you have to be very well prepared by the announcement of opportunity, because in no way one can write such a proposal in such a short time without prior preparation. One of the largest tasks that we had as a science contributors, like what I did mostly, is outline science traceability metrics, which is STM. It's very well used acronym. And it's determined by the announcement of opportunity, how it should look and what it requires to have. And this one is our probably not a final one, but this is how it looks like. So you can see that it goes from the top goals here in this left side, subdivides our link the current climate to long climate record goal into objectives. Basically, those were 2 sub-goals that I showed you before. And it goes down through the sub-objectives and even more separated investigations towards the measurement requirements. So each of these parts has the requirement of what we want to measure and with what precision we want to measure, how often we want to measure it. So all this then translates into requirements for instruments, what resolution they need to have, what time cadence they need to have, how the orbit should be done for them to be able to image specific places at specific times. And the last column is basically stating which instrument does that. So this traces our scientific goals toward which instrument we want on this mission. This is the most important part of science team work. So this, we spend a lot of time on this table. So we are now about here. I want to skip several things here. The proposal conference, as I said, it's just NASA informing us. The notices of intent we have submitted. This of its competitive programs, and basically you have username and password. You can sign in and see what's which programs are open. You can submit your proposals, and yeah. So final a little fact sheet about our final compass proposal. This was our proposal, and it was at the end 378 pages long. That includes everything. There is some tables that NASA wants you to fill in, which like also half of this proposal maybe is those tables. And just the table of contents was 5 pages, which included, here is all the list, and not that I can really talk about everything in this short time, but maybe most important ones are science investigations, that the chapter D, science implementation, chapter E, that talks about all the instruments and data management plan and science team that supports each of the instruments and which roles they are. F is a mission implementation, which talks about mission design, how spacecraft flies, which orbit it takes, what it observes when, and all related parts like mission operation, ground systems for downloading, uploading the data, all that. G is very, very important part together with H. So that's the part that I did not really do. I kind of course, seen it and participated in it, but we have project management and budget analysts who is doing that part. And that's basically calculating all together how much will it cost to run all this mission. This done is not on very detailed level at the stage of the proposal, but still the level is pretty much quite high. Student collaboration plan is optional in this proposal, but one can include how students would be involved in the mission, and all the additional documents from resumes of everybody who participates, how we deal with planetary protection. For example, we didn't need to because we are flying on high orbit, so we are not actually going to the surface, but if you propose a mission to go into the atmosphere surface, you have to deal with that. You explain the heritage of basically what was already put in and what which instruments already flew and so on. So a little bit about our proposal, and I see that I'm already quite late. I have a lot of things. Example, talking about TRL. We did not have technology readiness level of our spacecraft on very high values because we were using Astrolab spacecraft that was built by us for the Emirates Mars mission, and that mission has not flown yet, so we cannot claim the high level of development, and that's why we have to kind of try to convince NASA that it will be fine, that it will fly and it will work, which was at the end one of our major weaknesses, that basically NASA thinks that it's too high risk for them to take now on the spacecraft that never flew. So that's one of the big dings that we got for this proposal. But we wanted to use our own spacecraft. For once, it's much cheaper, and also we want to support developing technology in the house, so advance our lab capability instead of paying somebody else to do that. Here is an outline of how our mission design looks like. So you can see the timeline with the launch in 2026. So we would have about 6 years to build the spacecraft and fly it, to see the preliminary primary science orbit and all that. So that all was developed for the proposal. So, as I said, I want to talk a little bit about this part, about evaluations that we got. And basically, this is about how NASA evaluation process work, what NASA is paying attention to in the selection of such proposals. So after you submit your proposal, you get back 3 forms, Form A, B, and C. Each of them talks about a part of your proposal. Form A talks about scientific merit of your proposal. So basically that's the biggest part, that's the science part, what science you propose to do. And it takes 40% of your evaluation, this Form A. Scientific implementation merit is basically what is to be we have selected to solve our questions, and if we done this correctly. Mission implementation feasibility and cost risks, Form C, basically talking about how expensive the mission is and which risks are involved. So if something doesn't work, usually it means delays, more investment into the mission. So it's getting on the high risk for NASA to take on mission like that. So Form C and Form B take 30. So in more details about Form A and Form B implementation method, you get a grade from excellent to poor. And I think it's more or less intuitively understandable. You want to be excellent, you don't want to be poor. And I list here, I will not go through them, through these specific things that NASA is looking at. Probably the biggest one for Form A is likelihood of scientific success. So they want to evaluate how probable it is that you actually do what you set yourself to do. They also compare it to what NASA programmatically goals are at this time, and see if you basically fit what NASA is in a more global plan wants to do. Same with scientific implementation method, you get the mark from excellent to poor, and actually how are you doing your science, of all the instruments, of basically data analysis, how you plan to archive and deal with data, how you use it. And here is also evaluation of the team, of that everybody has a specific role, how well to collaborate if it's different institutions and things like that. So somebody who's writing a proposal needs to take care about that as well, to put that up too. The Form C is slightly different. It doesn't give you a mark. It ranks the proposal into low, medium, or high risk. And this is the fine balance to strike between the good science and the risk. So it's bad to be high risk, but a lot of interesting science you cannot do on the low risk level. If it's low risk, it's probably has been done already. That's why there is always a kind of strike for medium risk is the sweet spot to be. And basically this includes everything in the mission implementation, from the instruments, how well they are working, what happens if one of instruments doesn't work? Can the mission still succeed? Can it still do its primary goals? So after that, as I was saying, proposals are put into one of 4 categories. Category 1 is the best one. It's basically a perfect proposal, well conceived, with everything taken care of, from science to implementation to all the hardware working fine, and it's usually low to medium risk. Category 2 is one below, and there are several reasons that proposal can be put into this category. Very often it's high risk, so high risk but good science do fall into these categories, and this is exactly actually what happened in the last selection. Category 3 can be recommended for some further investigations. So basically this is a way of reviewers saying, this is interesting, this is possible to succeed, but it's not there yet. So NASA can decide to give some funding for advancing the, for example, instrumentation in this category, but usually it's not the mission that would be selected and flown. And category 4 is too many bad things happened in multiple places, so this is not recommended for selection. So normally the selection of step 1 happen from category 1 and 2. Some selection considerations that NASA tells us they are looking for. So first, as I said already, it's focused on category 1 and 2 proposals, and it takes into account all inputs from reviews and headquarters briefings and all the information they can gather about the missions. People who participate in the decisions come from division director of all divisions and their representatives, deputies focused on research programs and exploration, representatives from offices of chief engineer, safety, missions assurance, general counsel. So basically, almost all headquarters on NASA participate in this decision. But there are main overarching rules. All of those inputs are advisory. So no review can fund this mission, and NASA will do that. No, they don't do that. Final decision is with associate administrator. So currently is Dr. Tsubuhin, or a representative if Tsubuhin would have a conflict with like private or job conflict with the missions that are in competition. What happened in round 1 of the last discovery proposal? They received 18 compliant step 1 proposals, and by the rules of the program, maximum 5 of them phase a concept study of step 2. So in February 2020, they down selected these 4 missions to proceed to the next step. Da Vinci is a deep atmosphere Venus investigation of noble gases, chemistry, and imaging. So that's, as you can see from the name, with mission to Venus. Another Venus mission is Veritas, emissivity radio source in SAR topography and spectroscopy. So doing everything. Io Volcano Observer, IVO, and Trident, which is Triton flyby mission. So these missions now go into step 2 process. And here is basically what is happening to them right now. And I have this diagram, but I truly do not have enough information about it. So I know that the studies are already going on, and we will see in about a year about the next down selection decision. It's very probable that only 1 mission will go on, and sometimes it's 2, but we are expecting to be the selection to be quite harsh this time and have 1 mission that follows up. Okay, I think I'm taking almost all the time. I have a part about writing a successful proposal, which is I think we should kind of skip it. I will give you all this information. I just want to do a couple of slides about this. So this is areas ranked by importance according to NASA. This is what NASA told us we should be most focused on. And the first and the most important one, of course, is transformative science. So the science leads the mission. You cannot go other way around. You cannot say, I have this instrument, let's make a mission out of this. You have to have a scientific goal first and follow from that towards the instrumentation and the mission requirements. So how it is done in STM left. Second most important part is effective leadership. So the PI and PI core team is very important for NASA. So they do look at experience of the PI, because they are sure that leadership is what makes or breaks a mission. The third most important part is the team, so that the team covers all the important parts of science that is done or proposed to be done in the mission, that they have the required expertise, that they can support each other, that there is plan if the mission is very long about how the success in the leadership or even in just data processing will be targeted, how we will deal with it, because some people will retire, some new people will come into the team, so this also should be discussed. Strategic partners, so basically who are providing those important parts of the mission, like a spacecraft and so on in the first place, also very much evaluated by NASA. Fifth is system design, so the system engineer is the quite important person on the mission. So how all the things come together, how they interact, how the spacecraft is built, and how the instruments are put to it. That's the hardware part of system design. Then there is the part of system design about the mission, basically all the orbits and all the mission operations together. So that's the first place. And the management, so basically support of the institution for creating budgets, for running everything, doing all the evaluation and the important reviews in between. So all the management team is at the last place. I probably want to end with this typical problems discussion. So this is what NASA observed over many years in many programs, many submissions of proposals, that what is the troubles that bring down mission proposal. First of all, incremental science is not enough. So transformative science, they call that, cannot be just continuing observing something. Incremental advancements are for different types of missions, not for discovery program. There is often insufficient focus on that. Not only science is what you need to create a mission. All what we discussed, technology management and cost, is very important, and about 30% of step 1 proposals have a major weaknesses in this area. So science is very important, but support of science is also very important. You cannot fail on any of this. The explanation of science needs kind of strike a balance, because the people who are reading the proposal are very often the top scientists in that field. They are familiar with the field, but you probably writing proposal and you are the one who knows everything about it. And the next person who evaluating you is slightly less experienced in this area. So it has to be explained simply, but well, and should hit a nice sweet spot about communicating not at too low level, but not at too high level. And science, make science beautiful, is what NASA wants us to do. Leadership, team members cannot compensate for significant character weaknesses of PI. So if PI is arrogant or doesn't listen or is undecisive in problems, problem, and that's basically what takes proposals down as well. I already said about that. Even the best scientist does not survive a bad partnership, so you want your collaborators to be interested, first of all, is what they are doing, responsive. So they have to honor the deadlines, for example. if there is bad partnership going on, you probably even will not be able to submit a proposal. You need to balance the risk. In the whole history of NASA, only one high-risk proposal has been category 1. So being high risk, putting you into the bad position about the competition. And you have to pay attention to instruments. So 32% of step 1 proposals had major weaknesses in the instrument category. So some of the instruments did not explain maybe, or were not the required TRL level, things like that. So this is difficult, but it's still worthwhile exercise. I think I learned that during my proposal, and we know, and especially by now, that winning takes some losing. So it's an iterative process, and we will proceed and resubmit our improved proposal for the next, I don't know, next time in 2 to 4 years. That's the discovery cadence. You do need to use all the advantages that you have in the commercial and government sector to actually make the science. So it's very important to stay informed what is up top notch. And there is some other opportunities, the ones that I didn't talk about, CubeSats, venture class, and so on, so that create the possibility to participate in mission design with the kind of less responsibility, and maybe one day become a PI, or at least go on a successful mission. So that's all I was wanted to talk about. Ooh, that's a lot of talking. Thank you for your attention, and I'll take any questions.
Thank you very much. Thank you very much. Questions, please. Запитання, будь ласка. Там, хто буде задавати запитання? Мене чутно?
Чутно.
А задавати запитання в Zoom, там є така класна функція підняти руку, raise hand.
Maybe can do the video now.
Зараз, секундочку, я виведу учасників. Отак от. Запитання, будь ласка. Піднімайте руки. Зараз, секундочку. Я зараз увімкну своє відео, щоб потім було. Запитання, будь ласка. Зумовці. Зумовці, запитання.
Okay, I have a question. I joined it lately. I haven't got how to raise a hand. And which language to choose, Russian or English?
Either.
But for the measure of crowd, which one is more comfortable? Okay, I'll continue in English. Sorry. Yeah, so in general, I'm curious about Planck. Do you know the history how it was chosen?
No, that's not my area of expertise at all. But
in general, can you remind some case that won, and we might know about it?
Who can know about it? Good question. Most probably people who are on the main team, core team, should know about how they wrote the proposal. Another part is you can probably Google the actual proposal that was submitted. But was Planck maybe not the...
It was mostly European, not American.
Oh, sorry. But there was also NASA's some.
There was WMAP and COBE launched by NASA, if you're interested in CMB.
Oh, by the way, European selection is very, very different from NASA selection.
Oh,
So, yeah, European system is basically less competitive. So they have more of top-down approach than bottom-up, as we saying. So because they are smaller, they have a lot of programmatic decisions to make. They should kind of try to hoard their resources for their missions. So I actually would like to hear somebody's doing this presentation about the European Space Agency, because I was a little bit involved at my time in Switzerland, but again, Switzerland is not really part of ESA, so there's another level of complexity.
mhm.
Anya, by the way, I have a prejudice that Europe, compared to America, has a stronger focus on astrophysics. Like in astrophysics, ESA and NASA are nearly as good, while in the solar system studies, NASA is far beyond ESA. Is it true?
I also have such a feeling. I agree with that. Recently it becomes a little bit better with except of actually, but yeah, NASA's program is just that. I'm about European NASA's astrophysics part. How big is that? James Webb, of course, being built forever. So I don't know. I would agree, but I don't know if we should not take some kind of statistics to look into that.
Окей, thank you. Ще запитання у кого є в Zoom?
Recently, ouch.
Окей, good. Окей. Yes, yes, yes.
I just saw situation in my group that a postdoc submitted to a Emily Noether program. This our local funding program to be a professor and to make her own research group. And Emily Noether structure rejected her, and the reason was that there was some criticism, not very big, but the committee accepted that and rejected the application. How often such issues might occur in your situation in USA?
Very often. So if you're talking about research proposals, the selection rate is hovering somewhere around 20% right now. So you can imagine that you need to write 5 proposals to get one funded.
Mm-hmm.
So it's a very tough competition. As you saw, there were 18 proposals for these missions, and 4 were proceeded to the next step, and 1, maximum 2 will be selected. So mm-hmm. 1 over 18 is the chances to get a mission. So this is tough business. If you go to something like creating your own group, it's probably even more competitive. However, I believe that European funding is even more competitive. I hear very much that European, like Marie Curie, for example, has about 5 to 10% selection rate, so that's even tougher. So, but yeah, it's low. it's lower than healthy level. They say that statistics-wise, the healthy level for doing a good competition is selection rate of about 30%. So third of all proposed gets funded, then you keep, it's still competitive, it still produces enough good quality proposals. Not everybody who is doing something is getting funded, but at the same time, it's good enough rate so that people stay in the field and keep proposing instead of trying for several years and then falling off, going to do something else, some other jobs.
Thank you. More questions, please.
In the chat, we have an interesting remark from Eugene saying that the most significant difference between ESA and NASA selection models is that at ESA, they first choose interest in science cases and then proposals compete in budgets and risks, while at NASA, they first complete in implementations. Compete in implementations.
Well, I should say that that's the flagship model in NASA. So NASA, when NASA creates flagship missions, they say we want to go to, the last one was Europa. So we want to fly to Europa, offer us what you can do. And then the proposals come in about instruments that could be on that mission.
Okay, sorry, question from Vadim Kaidash. Please
Hello.
raise hand.
I already raised. Do you hear me?
Yes.
Okay. My question is a little bit different, maybe from others, about the continuation of the mission. Okay, if your proposal is okay, you got the mission, you studied, how missions deserve continuation? Say about LRO, Lunar Reconnaissance Orbiter. For more than 10 years, it's in orbit. How should I get a positive decision to continue my mission after the prime mission, after the continuation of the prime mission? How to live 10 years in space?
Yeah, good question. So NASA routinely does evaluation and re-evaluation of all flying missions. With Discovery missions, the cadence was 1 year until recently. So every year you have to write a report of what your mission is doing, and reports get reviewed. And all the missions in the same pot, so for example, all Discovery missions that currently are working, would get ranked and would get the mark, like excellent, good, and so on. So I did go through that with MRO. I don't know about, so MRO and LRO are the same pot of missions. They go basically at the same time. Sometimes you might hear the news that mission got excellent grades in their review for this, or mission gets good grades, and which missions then are supported for extended mission is again decision by NASA headquarters, very similar to what's done here with the selection of original proposals. You also have to propose the new science that you do. Mm-hmm. So the part of that review is that's what we did over the last 2 years, 4 years, whatever the period is, and this is what we propose to do to the next extended 4 years of whatever they're asking for. They recently made this less often because I know that people were complaining that they basically keep writing these reports and proposals and they don't have time to do the science. So the NASA listened and made it longer. I think it's 3 years for Discovery class now.
Okay. So I see. But if NASA don't have enough money, they would kill the mission, leaving mission, would kill the mission, would stop.
They do prefer to keep missions running as long as they are running.
Mhm.
So when your instruments start to decay, that's what will kill the mission most probably.
Mhm.
I think it's similar with ESA. That's why they killed Venus Express. The instruments were already almost all gone. I know that for Mars, they want to keep spacecraft even if just the antenna is working, just to transmit the data from other spacecraft. That's why also MRO is basically being saved for the case that we need it to be a relay for other missions, not because it will be used for science, but because it will be the big relay spacecraft.
Technical. Thank you.
You're welcome.
Thank you. Questions from Uliana, please. Microphone.
I already forgot. Yeah, continuing my question about how the reviewers might be suspicious to the project. Means if the reviewer might write, I don't like the project because I don't believe to the value of Planck value that you mentioned. Whether such review might be taken seriously, or well, I just heard about patients, so I'm asking.
So in NASA, there is never just one reviewer. So there is always a panel. Usually, if it's a research proposal, then your proposal will probably be read by minimum 2, but 2 to 5 people. So they, it depends slightly on which actual program we're talking about, but they usually write the review together, or each of them writes a review and somebody summarizes it. So there is never one person failure in this situation for NASA. Having said that, it still happens that the main reviewer just simply doesn't like, doesn't like this topic, doesn't like this person, whatever. So these things happen. Usually there is also a way to complain about the review if the author thinks that it's not proper. So, for example, if the review had a conflict of interest, which would be I am a competitor on the same topic and I want to bring somebody else down so they don't compete with me, that's a very valid reason to basically cancel the review of such a person. So, but this all is a little bit more on low-level details. It depends how specific program is organized, who is running it. If you can ask for clarifications, if you can ask for debrief, that's what debrief is for. Asking why my proposal was evaluated that way. So it's down to the specific situation and specific people. I had, I should say, some cases where I went through the whole debrief situation and asked to reconsider my proposal completely. So start from scratch because I think that the panel was prejudged to me or against me, I should say. So I did that once. It didn't bring me anything, but yeah, I have that experience. So I kind of, it's possible. That's maybe the biggest answer.
Wow, great, thank you. I haven't known till your talk that it's possible to send the the proposal for the reconciling.
Yeah, it's possible. It's not normal. So they will do everything in their power not to do that. That's for sure. But it's possible.
Okay, wow, thank you.
Thank you. Please, Alexei.
It turns out that the organizer of the meeting can't raise the hand officially. I'm just doing this. First, one more remark from Eugene. He writes, oops, sorry guys, it is the other way around. Technical implementation and risks are at the earlier stage of the competition at ESA. So he probably knows it better.
Maybe.
And one more question from me, a very general one. So, if we are here in Ukraine, working in our areas, and some of us being widely renowned specialists, what can we do as individuals or maybe as an organization to participate in space missions by NASA?
Well, so your main chance is to become a COI. COIs that are US based are getting paid by NASA. COIs that are not in US need to get support from their home institutions. So that's the biggest part. So basically, your observatory or your institution needs to say, I'm okay with this guy using his time that we are paying him for to go and be a COI on the mission. Participating and writing the original proposal is the best way to do it. It's also hardest way to start, to basically to get into that team is pretty hard. Basically, I would say you need to be talking to people who routinely do propose missions. You need to basically tell them that I want to be on a mission, I'm interested in this data, I want to help you to form the team, I want to support you in doing whatever data processing. A little side note, every COI on the mission has a specific role. So, for example, my role was for Compass was to it's kind of synergy task. So I would be the person that talks between several instruments about combining their observations together. So they would not be fighting for time when they want to take measurements. I would be the person saying who has a priority at each specific time and which data should be taken simultaneously and which can be spread in time. So I would manage scientific observation planning of multiple instruments. So that was my specific role on the team. Even so, I'm interested in actually imaging the surface. I'm interested about the data that maybe atmospheric science together with surface gets. So that's my scientific interest in the mission, but I do have a task as a COI on the mission. And that's a standard thing that each COI needs to do something apart from their scientific interest. So they have to be useful somehow to the team and to the mission. So finding that and talking to PI or deputy PI or the core team of COIs, instrument leads, and all these people is what gets you on the team.
As it is probably the best to do at an early stage of mission development, it means that we might contact our American friends, reminding them every now and then, do you please have any mission concept under consideration? Can you please need our help?
Yeah. But it's also fine to come in later in the stage. It's hard to get COI membership when the mission is already like in phase A or further, so when they're already building it. It's harder, but it's not impossible again. Usually so you get some kind of team member status on that stage. So that's why I'm team member of many on many missions, many instruments. But this was my first kind of possibility to be a co-I because I was there from the beginning.
Thank you very much. Are any questions from Zoom? No. We
By
have...
the way, I wanted to say, Uliana, if you click on participants in the, like, there is bottom panel has participants. You can click on participants and then the side panel opens with all the people, with all the names. And there is raise hand button
Yes.
underneath the list.
We have
I found it. Thank
questions in questions? Ulian? No? We have questions in from Facebook. Оксана Шалыгина von Wachenhausen says, nice, great talk, thank you very much, and has a question. Ganna, do you plan to be PI of some mission?
Not yet. I think I'm not yet on the level that will be successful. I have a dream to be a PI sometime, but it's years away, I'm pretty sure. So I first want to be a co-I on a successful one sometime.
Thank you. Are any more questions? No. Окей. Я буду українською. Ми будемо закінчувати наш семінар. Дуже таке велика подяка, Ганна, дуже цікаво, все було здорово. Давайте, може, хтось хоче буквально сказати з учасників на Zoom по одному слову слухачам. І будемо завершувати наш семінар. Я думаю, що все виходить здорово. Будемо продовжувати. Я знаю, Олексій Голубов хоче...
Ну, оскільки Аня дала мені гарну пораду контактувати з моїми американськими друзями і напрашуватися до них в місію, ось я почну з того, що попрошу Аню до неї в місію, якщо її місія буде. А я певен, що вона буде. Будь ласка, Аня, звертай на нас увагу. Ми
Добре, буду.
багато в чому можемо тобі допомогти. І знаю, що наша робоча сила дуже дешева за американськими мірками. А якість достатньо висока.
А бачите, як цей коронавірус зрівняв наші можливості. Багато конференцій, мабуть, ви вже бачили з тих, що були для нас дуже недоступні, за того, що важко поїхати, дуже дорого, коштовно. Тепер вони переходять у формат онлайн і в більшості випадків взагалі free of charge. Будь ласка, хтось ще хоче сказати? Давайте, у нас зараз в Zoom знаходиться 14 учасників. Классная традиция, я знаю, започаткували в відділі малых сил.
Спасибо большое, очень интересная презентация. Хотелось расшать ее, пожалуйста. Пришлите, пожалуйста, хорошо?
Хорошо, кому слайд?
Мне?
Хорошо.
Вот мне голову, да?
Давайте
я знаю
пошлю,
хорошо.
Кому-то одному, а вы уже распределите. Я же не знаю
тогда
ваших
Лёш.
имейлов. Да.
Я нагадаю, що запис автоматично він буде на Фейсбуці.
Я хорошо знаю систему европейского космической миссии отбора, то есть я там участвовала, но проект на самом последнем был загублен, это Марко Поло проект. Там, конечно, все по-другому, я бы сказала. Спасибо большое.
Дякую. Уляна підняла руку. Уляночка. Льоша, ви мікрофон забули увімкнути.
О, простите. У меня чисто эмоциональное восхищение по поводу темы этого доклада. Это очень классно в связи с тем, что я недавно узнала, сколько моей научной руководительнице лет и ее постдокам. Ей 31, а постдоку, с которым я консультируюсь, 29. То есть в таком молодом возрасте уже могут сделать успешный проект, рабочую группу на около 20 человек, и это работает уже, ну, я так предполагаю, что около 5 лет. Просто сразу открывает глаза, как это делается, и то, что вот люди приблизительно моего возраста это делают. Это вау.
Дякуємо, здорово. Будь ласка, хто ще хоче сказати пару хороших слів? Підніміть руку в Zoom або в екрані.
Как тут raise hand сказать? Так вот. Да, наверное.
Ага, викликай, да, будь ласка.
Да, но я хочу сказать, слышно меня, да?
Так.
Что мы зависим от насовских миссий очень сильно. Мы обработчики, к сожалению, сейчас во многом обработчики чужих данных. Или, к счастью, обработчики чужих данных. Вот. Поэтому будем, потребители чужих данных, вот, к сожалению, потому что собственная материальная база не очень высока, не очень хороша. Вот. Поэтому надо действительно нам как-то участвовать, по крайней мере, контактировать на этапах, может быть, научного осмысления вот, миссии. Хотя, так как мы не участники НАСА, мы не можем претендовать на какое-то, финансирование, вот, а из собственных источников вряд ли найдем. Вот. Но надо всемирно поддерживать наших коллег, когда они делают пропозал. Вот. Ну, это такое общее замечание. И спасибо большое за доклад. У нас редко, я боюсь, на национальном уровне мы обсуждаем, как делать пропозалы, но пропозалы насовские мы обсуждаем весьма редко. Ну, там были случаи. Вот. Поэтому это очень хороший доклад, хорошая тема. Спасибо.
Дякую. Ще хто хоче, підніміть руку, будь ласка.
Присоединяюсь. Привет, Аня. Спасибо большое, все было классно. Для нас это живой мир, так сказать, который обычно доступен только через самолет, а здесь как бы присутствует рядом. Спасибо большое.
Пожалуйста, очень приятно.
Дякуємо. Ще, будь ласка. Будь ласка. Є бажаючі, підніміть руку в Zoom або в камері. Ну, давайте я тоді ще покажу тут, у кого вімкнені камери. О, Василь Григорович. Василь Григорович, хочете щось сказати? Мікрофон тільки вімкніть. Василь Григорович, мікрофон увімкніть.
Спасибо, Аня, за чудесный доклад. Мне тоже приятно очень было послушать. Ну и, естественно, на английском, поэтому я немножко тоже приятно, поскольку вот мы в отделе практикуем такие небольшие семинары. Ну, а здесь вживую послушать американскую речь очень хорошо. Ну и так, в целом, конечно, очень интересно, как это все делается. Спасибо большое.
Дякую.
Пожалуйста.
А хтось ще хоче? От я отак можу навіть показати.
У меня вопрос к директору. Он почему на работу ходит в карантин?
А он дежурный.
Микрофон, Вадим Григорьевич. Микрофон.
Живет.
Вадим Григорьевич, микрофон.
Потому что капитан покидает тонущий корабль последним.
Типун вам на язык насчет тонущего корабля.
Предварительно перезаразив всех крыс.
Да.
Ну, про крыс не будем. В общем, вот, смотрите, подождите, я показываю.
О,
А,
о, астрономі. Нічого собі.
звезды видно?
Ага, астрономічна маска.
Ясно.
Здорово.
Детектора маска со звездами.
Здорово. Хто ще хоче сказати? Зараз давайте, хто у нас є? Нема. Ну ладно. Тоді будемо сьогоднішнє наше засідання дуже таке, можна сказати, домашнє в прямому і переносному сенсі слова закінчувати. Слідкуйте, будь ласка, за об'явами. Я думаю, це не останнє наше засідання семінару. Ну, поки що от в такому дистанційному методі, дистанційному режимі. Я завершую трансляцію, завершую запис. Секунду. Так.